Hello everybody. Today I will explain the configuration of these 4 5 kW batteries and 2 SPF 5000 HVMP inverters in parallel. First of all, we will talk about the wiring part. About the batteries, we can connect the communication line first. From this inverter, we connect the communication line to this BMS port. Then connect to the RS485 port of this battery. This is our battery host. About the connection of the battery communication line from this RS485 port, and then connect in series to the other second, third, fourth batteries. At the same time, when this line is connected, then we need to set the DIP switch for each battery. For the first battery, we need to dial up the first one of the DIP switch, and the second battery, dial up the second one, then dial up the first one and the second one in the third battery, and the fourth battery, dial up the last one. It's a connection method corresponding to the binary. This is all we talk about how to connect with each battery. We talk about the power line. We need to connect the red positive pole of all 4 batteries to the positive pole of the air switch. Then connect the black negative pole of all 4 batteries to the negative pole of the air switch. Next, on the other side, the air switch and the inverters are connected like positive to positive, negative to negative. This is the wiring of the whole battery. Now is the part for inverter. The inverter is mainly divided into 2 parts. One is the input to the grid of the inverter. This is the AC input. The red line is the line L. The black line is the line N. The red and black wires of inverter 1 and inverter 2 should be connected in parallel, then connect to the grid. This is the input part. The next part is communication. This is the directing stream line of the current. After we connect the 2 inverters in parallel, we also need to connect inverter 1 and inverter 2 one to one with the directing stream line. The RS485 and RS232 communication lines are also need to connect one to one in series. Then tidy up all the lines. This is the process of wiring. What should we do after the lines are connected? First, we need to turn on the machines and debug. We can see a power switch in this place of each battery. Press this switch button, the battery will be turned on. We need to turn on all the batteries. After we did this, we need to turn on these 2 inverters. We can see the on and off button in this place. Generally, the factory setting is off. Before we debug or set the parameters of the inverter, the switch needs to be kept in the off state. The on state only be used when it's running. So I turn it off first. Then we look at the inverter screen. We know there's communication between the battery and the inverter. So before we turn on the inverters, we need to configure the BMS protocol of this battery. Parallels also need to be confirmed. First of all, we need to long press the enter button. Enter the setting menu, then press this up and down button. We can find the item 05. We set it to L1 through item 05. Then we press the enter button. Press it once. Then when we press again, it will automatically jump to item 36. We can see it's also L1 here. We just press the enter button to confirm, then press the ESC to exit. In that way, our communication is set up properly. At the same time, because these 2 inverters are connected in parallel, so we need to set the inverters in parallel mode. There are 3 parallel modes. These modes are set via register number 23. It's register number 23 now. Here are 3 modes. This is standalone. This is parallel, PAL parallel. This is SIO, the standalone mode. And this one, the 3-phase mode. When we need to parallel the single phase, we choose the PAL mode and press the enter button. Then press ESC to exit. The other inverters operate in the same way. After this configuration is all set up, let's turn on the inverter. The inverter has 30 seconds self-test process. After 30 seconds, the inverter will start to charge the battery. Like now. So far we didn't connect the inverter to the PV, so now the battery charging is from AC. We can see this side is the output voltage, and also we are not loading right now, so we can do a small load test later.